Hello, good day everyone. Today is another wonderful time and we shall be discussing the functional components of a computer. So we will describe the functional component of the computer, and these functional units are regarded as the computer hardware, which is also known as the physical or functional unit. And we will discuss the role the motherboard plays in supporting this functional unit. So at the end of this particular lesson, you should be able to list the functional units of the computer, explain the component of the central processing unit, distinguish between the two main types of memory, and finally, you should be able to list the input and output devices of a computer system. Now, fully into what we have today, the functional unit of the computer. This is the collection of physical elements that makes up a computer system. The hardware of a computer system can be classified into three distinct units. First is the central processing unit, also known as the central processor. Second is the memory, and finally we have the peripheral units. The central processing unit. This is regarded as the brain of the computer. The same way your human brain performs the thinking for you, the processing for you, and coordinate other activities within your body systems. So it is the central processing unit of a computer system. The CPU executes stored program and does all the processing and manipulation of data. The CPU performs all types of data processing operations. It stores, provides intermediate results and instructions. It also controls the operation of all parts of the computer. This means that most of the computer activity is centered on the CPU. Here is a chart showing the interconnectivity between the input and output and the role the CPU plays at the center to coordinate both the input and the output function. So the CPU broadly is divided into three major parts. The control unit. First, the control unit controls the operations of all the parts of the computer but does not carry out any actual data processing operation. It is responsible for controlling the transfer of data and instructions among other units of the computer. It manages and coordinates all the units of the computer. It obtains the instruction from the memory, interprets them, and directs the operation of the computer. It coordinates the input, as you've seen on the last slide, and the output devices for transfer of data or results from storage. However, it does not process or store data. That should be well noted. Then we have the arithmetic and logic unit, usually abbreviated as the ALU. It is a digital circuit that performs arithmetic and logical operations for the computer system. The ALU performs arithmetic operations such as addition, subtraction, multiplication, and division through the internal logic capability. Logic, as you know, is a method of reasoning or argumentation. The computer internally reasons and tests various conditions encountered during processing and takes action based on the result. It contains logical circuitry used for comparing operations on operand unit. Now, the operand unit is a term used to describe any object that is capable of being manipulated. For instance, if you punch 1 plus 3 on your computer, the number 1 and 3 are your operands, while the operator is the plus sign. So the ALU is a basic foundation of the central processing unit of a computer. And even the simplest and smallest microprocessors contains one for the purpose such as maintaining dates and time, as seen on this particular computer or your computer you have with you or your phone. And in this category, we'll talk about the memory. Now, the memory refers to the physical devices used to store programs. And programs are sequences of instructions or data on a temporary or permanent basis for use in a computer or other digital electronic devices. The computer memories section is sometimes called primary storage, main memory, or simply memory because it functions similar to our human memory. In reality, as a chip on the motherboard, it is actually a semiconductor device, and it has fast processing speed, high reliability, and low power consumption. The memory serves four main purposes. The first three are related to retention of data during processing. The fourth one is concerned with program statement transferred from an input device. So let's take them one by one. First, data is transferred from an input device such as keyboard to a storage area in the memory where it remains until the computer is ready to process it. So there's an aspect of the memory that serves that function. The second is a working storage area within the memory also holds both the data that is being processed and intermediate results. So you see, while you are sending your data into your system, one part of the memory holds it. While you are processing it, one part of the memory holds it. And thirdly, the memory retains the processing result in an output storage area. So, and the fourth is storage area contains program statement transferred from an input device. So here is an organogram of how a computer memory is structured. See, you have the internal, the main or primary memory, which is divided into your ROM, which is actually a non-volatile area of the computer system. Whatever is programmed there, is stored there, remains there on permanent basis, except you decide to wipe it off. Whereas the RAM, which is the random access memory, is a volatile area. If you don't transfer what you are doing there, which is temporary, to a permanent storage area, once your computer shuts down, it's gone. So we have the external storage, which are your hard disk drive, your SSD, which means the solid state drive, your compact disk, and your USB flash drive. Of course, gradually the compact disk is being phased out, but USB flash drive is still very much in use. So the subdivisions of your random access memory are shown on this slide. Now, the read-only memory will concern ourselves with the broad scope, the read-only memory and the random access memory. Now, in computers, it is useful to have instructions that are used often to be permanently stored inside the computer. The ROM enables us to do this without losing the programs and data when the computer is powered on. So programs tailored for specific needs and are installed permanently in ROM and are called microprograms or firmwares. Now, the random access memory. In the computer, the RAM is the working memory. Data can be read, that is retrieved, or written, that is stored in the RAM by providing the computer with an address where the data is stored or where you want it to be stored. So we have different types of RAM, which are the SRAM, as you can see on the organogram, the DRAM, which is the dynamic random access memory, and we have the SDRAM, the synchronous dynamics random access memory, respectively. So we look at the motherboard. The main function of the motherboard is to hold the computer's microprocessor, which is the CPU, and everything else connected to it, and let everything else connect to it. Motherboard majorly consists of the microprocessor, the BIOS chip, which is usually a ROM, and various slots. Now here is a picture of a relatively old motherboard, but for the sake of this class, it will be good for illustration. So you see the board is somehow dusty. So you see this is where your processor sits and the cooling fan sits on it. So this is the socket where your processor is mounted, which is the brain of the computer. So we have some chips on board, and we have sockets like the PCI slot, which is the peripheral connection interface, the AGP slot, accelerated graphics port. We have your memory slots, which are 4 in number. You see yellow and blue. Sometimes you see it as black sockets. So we have other sockets, which are the IDE sockets on board, and a few electronic components like the capacitor on board. And look at the external ports that are connected to your USB, your printer port, this is your printer port. You have your mouse serial port there on old boards like this. So, but most of these ports are already replaced with just your USB and Type-C port in our modern computers. Peripheral unit, which is the last to be considered. The computer peripherals are devices that are used to input or send instructions or enter information into the computer system for storage or for processing, and to output processed data to a human operator, or in some cases to a device controlled by the computer. The peripheral includes memory storage devices. Now, broadly speaking, we have 3 main groups in this unit: the input, the output only, the input only, and sometimes you can have the input output, and we have the storage, and lastly, which is not so common, the networking devices, which is relatively optional if you don't want interconnectivity with your system. So the input and output devices, for input devices, these devices send data to the computer, and common examples are the keyboard, as you can see, or embedded keyboard if you are using a laptop. We have the mice, we have the scanners, we have the microphones and webcam, as I'm using for the recording of this particular class. We have output devices, which are used to receive process data from the computer and present it to the user. Examples are your monitors, your printers, your speakers, and your headphones. You should know we currently have non-impact printers. For older generations, we have impact printers, but we have non-impact printers, which are primarily your inkjet printers and your laser printers. And we have different types of speakers depending on how audible you want it to be. The monitors, we have modern monitors that are touch screen, which can serve both input and output functions. You can touch it, like mine, I can touch it, and it's very, very sensitive. Storage devices store data for later retrievals. Common examples are your hard drive, external hard drives, USB flash drives. They are peripheral components. And networking devices enables communication with computers and other networks. Common devices are your modems, your routers, and network adapters. So in summary, today you have learned that the hardware is divided into 3 major parts, which are the functional unit, the central processing unit, the memory, and the peripheral unit. They are interconnected electronically by electrical circuits to permit communication between them, and the interconnection allows computer to function as a system. You also learned that the peripheral unit includes input only, output only, input and output only, like a touch screen or monitor of your computer. And you have input only devices, output only devices. Then we have other ones like the storage and the network devices. So it's another wonderful time. Thank you for listening. Till we meet again, have a wonderful time.